All right, so I don't think I taught this, but it's been so long since we were doing these things. So there is a rule that says if you have x to the m over x to the n, tell me if I did this. So notice, remember, when you have same bases and you're multiplying, you add the exponents. When you have same bases and you're dividing, meaning a fraction is a division problem, right? Every fraction is a division problem. This is x to the m divided by x to the n. The answer is, instead of adding the exponents, you subtract the exponents. Multiply, you add the exponents, Caleb? Multiplying, you add the exponents. Dividing, you subtract. So your answer is going to be the base with the top m, the top exponent, minus the bottom exponent. So that is the rule that we're going to follow, that we're going to use. So if I gave you x to the 10 over, this is number 1, x to the 10 over x to the 4, it would be x to the 10. Think of this fraction line as like a huge minus sign. 10 minus 4. 10 minus 4, which is x to the 6. Okay? So if I gave you, let's say I gave you this, x squared over x to the 8th. So I have same bases, so I write the base, and it's the top exponent minus the bottom exponent. So that means x to the what? Negative 6. But I can't leave an answer with a negative exponent.
Oh, so what
So,
if you like 1 over x to the
yeah, there's a hidden 1 here, so that's going to go downstairs. So it's 1 over x to the positive 6. Right? Okay, so let's do number 3. What if I gave you something like this? X squared times x to the negative 4 times x to the 5 all over x to the 3rd. Okay, this is a combination of two rules. I'm going to simplify my first one, my numerator, by multiplying same bases. So I'm going to add all these together. So I'm going to make it simple. So it's going to be x to the 5 minus 4 is what? 1, right? 5 minus 4 is 1. 1 plus 2 is 3. So x cubed over x cubed. What does x cubed over x cubed equal?
1?
1, right. All right, let's try another one. I didn't mean that to happen. Jeez. Okay. If I have x to the 4th times x to the 5th over x to the 6th, that would give me x to the 4 plus 5 is 9 over x to the 6th, which is equal to x to the 9 minus 6, which is equal to x cubed. Right? Make sense? Right? I'm going to do one more problem. Okay? 5. So give me one. Don't put your notebooks away. This is one more problem. 5. Okay. Hang on one second.
Who was that?
That's Manuk, I figures. Okay. Okay. All right. Let's say I gave you 5x to the 5th over 10x squared. All right. This is combining now coefficients, numbers, with the variables, right? So I first simplify my coefficients. What is 5 goes in, I want 5/10 could be simplified as, divide 5 by 5, that's 1. 10 divided by 5, that's 2. All right, so I put this, I go equals, and I go like this, 1/2. And I have a long line here, so I can put my x wherever it should be. Does that make sense?
Yeah.
All right. I have x to the 5 over x to the 2. Okay? The way I think of it, it's 5 minus 2 is 3, right? That x to the 3 is going to go upstairs. Okay? You with me? It's going to go upstairs. Another way to think of it is if I brought the smaller exponent up, x squared, look at this. This is a trick. If I brought this x squared across the fraction line, what would happen to the 2 exponent? If I brought this across the fraction line, what would happen to the 2 exponent?
Would it?
It would change sign. It would become negative. So look at this. I could cross this out and do a minus 2 right there.
Oh, I got you.
And that means x to the 3rd. Does that make sense?
Yeah.
Okay, so that's it. That's all you need. So I've got the homework here. Let me just turn this off.